Numbers, patterns, predictions. It's like trying to crack a puzzle, right? But what if I told you there's a method that makes this puzzle surprisingly easy to solve? Welcome to day 13 of the 30 Days of Machine Learning series. If you're new here, don't worry. You can click right here to access the full playlist and catch up on all the learning so far. And hey, don't forget to subscribe so you're always one step ahead in your ML journey. In this video, we're diving into logistic regression, the cornerstone of classification problems in machine learning. So whether you're just starting out or looking to strengthen your ML foundation, stick around. By the end of this video, you'll see how logistic regression can unlock the power of predictions in your data. Let's jump in. Let's import the essentials pandas for data, NumPy for computations, Matplotlib for visualizations, and Seaborn to make those visuals stunning. Loading the dataset with pandas, then using head to peek at the first few rows for a quick overview. Checking the column names to understand the structure of our dataset. Removing unnecessary columns to keep our dataset clean and focused on relevant information. Converting diagnosis values for easier analysis, replacing M with 0 for malignant and B with 1 for benign. This ensures our data is numeric and machine learning ready. Creating a violin plot to visualize the distribution of radius mean for both malignant and benign diagnoses, giving us a clearer comparison of the data's spread. Calculating correlations between features and visualizing with a heat map, helping us quickly spot relationships and trends in the dataset. No annotations to keep it clean. Selecting key features for analysis and creating a pair plot to explore their relationships. By using diagnosis as the hue, we can easily differentiate between malignant and benign samples across these features. We are separating the target variable diagnosis and scaling the features between 0 and 1. Normalization ensures all features contribute equally, preventing larger values from dominating the model's learning process. This is crucial for effective machine learning. Splitting the data into training and testing sets, reserving 30% for testing. This allows us to train our model on one set and evaluate it on another. We are printing the shapes of our training and testing sets to verify the split. This ensures that we have the correct number of samples for both features and labels in each set before moving forward. Initializing the logistic regression model with a maximum iteration of 200 and training it on our training data. This will help us build a model that can predict diagnosis based on the features. Evaluating model performance by checking its accuracy on the test set. Generating a confusion matrix to compare the true labels and model predictions. Helping us evaluate performance by highlighting correct and incorrect classifications for both malignant and benign diagnoses. Visualizing the confusion matrix with a heat map, where the annotations show the exact counts. This helps us clearly identify the number of correct and incorrect predictions in the model. And that's a wrap for logistic regression. We've built, trained, and evaluated our models step by step. But wait, we're just getting started. In the next video, we'll dive into linear regression, exploring how we can predict continuous values. Click on the screen to continue, and let's keep this learning journey going.